So we've observed that matter has different properties. I personally don't care for tomato soup, but I do like chicken noodle soup. The characteristics that distinguish one substance from another are called properties. And of course, we can take the properties and categorize the properties as well. So we break the properties into two different types, physical properties and chemical properties. So a physical property is one that can be displayed or observed without changing or altering the nature of the substance. You don't have to change the composition. So gasoline has a distinctive odor. When you're pumping the gas and you get a whiff of that and you smell the gasoline, that doesn't change what the gasoline is composed of. You're just observing its odor. Other examples of physical properties are the taste of something. Don't taste the gasoline. Its color, its appearance, is it shiny or dull, its melting point, its density. You can observe these things without altering the substance. A chemical property is one that a substance displays in the process of changing its composition. So gasoline is flammable. You demonstrate the flammability of gasoline and you've changed the gasoline into other things. You've destroyed the gasoline. Other examples are corrosiveness, acidity, toxicity, etc. When those properties are demonstrated, the substance is destroyed. So let's talk about physical properties. So the atomic or molecular composition doesn't change when you demonstrate the physical property. So water boils at 100 degrees Celsius. Here we have a pot of water boiling. So it's going from a liquid state into the gas state. When we boil water, the individual particles are not altered. It looks like the water's disappearing, right? And it's going from a liquid state into the gas state, but the individual molecules are not destroyed. They are still water. And this water, when cooled down, will condense back into liquid water and have exactly the same properties that it did before. So it changes from a liquid to a gas, but it's still water. A chemical property, though, when you demonstrate it, it changes the substance. So iron rusts. The susceptibility of iron to rusting is a chemical property of iron. When we demonstrate that, here's a nail getting rusty. In the nail, there are iron atoms arranged in a nice crystalline structure. When it rusts, oxygen gets included in the structure, and now the iron oxide or rust has different properties. It has a different color and it has different structural qualities. An iron nail is very strong, but after it's all rusted, it becomes very weak. The rust will flake and break, and it's not pure iron anymore. So in demonstrating a chemical property, we change the composition of the substance. So let's identify these properties as either physical or chemical. So the explosiveness of hydrogen gas. So I heard physical and chemical. When hydrogen gas explodes, does it change? It does. So this is a chemical property. The bronze color of copper, that's physical. You can look at a penny and observe its color, and it doesn't alter the penny at all. The shiny appearance of silver, that's a physical property. The ability of dry ice to sublime. Subliming is changing from a solid directly into a gas or a vapor. That's physical. That might not be immediately obvious. So this is an example of a state change. It's going from a solid to a gas. That's kind of unusual, but think about water. When water melts, when it goes from a solid to a liquid, is it still water? Yeah. You could just cool it down and freeze it again and make it into a solid. When it boils, goes from a liquid to a gas, it's a physical change. Any state change is a physical change.